So, why is this Lorentz force so important? I mean, all the other forces we kind of jammed into one section. Field forces, which Lorentz force kind of fits in another section. Why am I taking the time to talk about the Lorentz force individually? Well, it's because of this. What I have here is I have a piece of wire. Okay, imagine that this piece of wire is eventually connected back to itself, and there's a light bulb. Okay. It's a piece of copper wire, which means that I have a lot of free electrons floating around on the surface of that wire. Okay, and then above that wire I have a magnet. The magnet is generating a magnetic field that comes out of the north and circles through to the south. Okay. Now we know that we have this QV cross Lorentz. And so if I have a moving charge in a magnetic field, that charge will experience force. But motion is relative. Okay? That's relative. So if I were to take the point of view, let's say, of the electrons, and I have this magnet, and I have it suspended, and I'm going to let that magnet fall through that coil. Okay? So it's going to end up gaining some speed. It's going to go through that coil. Okay? If I take the point of view of the electron on that piece of wire, what do I see? I see a bar magnet dropping by me, okay, moving by me like a freight train. But if I take the point of view of the bar magnet instead, what I have is I have a piece of wire moving in this direction. Okay? So what I can say, if I take the point of view of the bar magnet, it sees the piece of wire coming up towards it. Cool? So that means that every single electron that's in that piece of wire has, and there's no current flowing through that wire, has a velocity in this direction. It's all moving up. Cool? Well, that's interesting. So as the bar magnet travels through, I'm just going to take a cross-sectional piece of that wire. As the bar magnet starts traveling through, it has that magnetic field. It's a ferromagnetic piece of material. That bar magnet will generate. That bar magnet's magnetic field is going to go something like that. Okay? So at this point, we have a magnetic field on any electron on that piece of wire being pushed in this direction. Okay? It's experiencing a velocity in this direction from the point of view of the bar magnet. Okay? So looking at this, QV cross B, the object has a velocity in this direction, but because it's an electron, it goes in this direction. Right? So putting my right hand, not my left hand, putting my hand in the direction of velocity, and turning it. So we've got that QV pointing down. Okay? Then I turn my fingers into the direction of the magnetic field, this way. So this electron is being pushed towards it. Okay? It's coming out in this direction. If we look at the other side of the coil, this side, the electron, the velocity, the magnetic field is in the exact opposite direction. So I'm pushing the electron this way. And on this side, I'm pushing the electron into the void. So what I have is I have every single electron on this side being pushed this way, and every single electron on this side being pushed